Okay, let's get down to business and factor a trinomial expression. So the first thing I want you to understand is that we've already learned two rules, GCF and grouping. Neither one of those rules will work here, and let's talk about why. If I said do the GCF rule, I would say what do all the terms have in common, and let's divide that out. So if we look, do all the terms have a number in common? Well, 1, 11, and 24 can all be divisible by 1. But is dividing by 1 going to change that expression? No. Do all our terms have a variable in common? X squared, x, no x. So no, they do not. Because this term does not have an x, we cannot divide them all by x. Hence, we have no GCF. I would look at grouping. Well, grouping is very specific. You can only have 4 terms to do grouping. How many terms do we have here? 1, 2, 3. So grouping is out. So that's why we need another rule. And this is obviously called the trinomial rule because we have 1, 2, 3 terms. When you do the trinomial rule, the first thing is you have to make sure your trinomial is written in the correct descending order. Is this trinomial in the correct descending order? Yes, it is. Okay, now, to factor a trinomial, the first thing you do is put 2 sets of parentheses. Every time you factor a trinomial, the answer will always be 2 binomials. Guaranteed. 100%. To factor a trinomial, your answer is 2 binomials. So I put my 2 sets of parentheses. Factoring a trinomial is like doing backwards FOIL. So I'm going to write up FOIL up of here. We know the acronym FOIL stands for first, outer, inner, last. So which term is first? That's right, x squared. Which term is last? That's right, 24. Now there is no outer or inner term because remember when you do outer and inner, you put them together, they're usually like terms, and that's what makes the middle. The middle term is the outers and inners put together. So every time I factor a trinomial, I think we're going to do backwards FOIL. Now you'll hear me say for the rest of the semester, this is an easy trinomial, easy. And the reason why is the leading coefficient is understood to be a 1. And why is that easy? Because that means there's only one way to multiply to get this first term. There's only one option. When I ask you what can you multiply to make x squared, everybody's going to say the same thing, x times x. So every time the leading coefficient's a 1, there's only one option that goes first. That's what makes it easy. After you ask yourself what multiplies the first term, then you got to ask yourself what multiplies to the last term. Don't worry about the middle yet. You go to the last term. Here's where the fun begins. Now remember, I've been teaching for over 25 years. I can do this in my head. I've been doing this day in, day out for 25 years. You guys have not. Therefore, you need to write stuff down. The question is, what multiplies to 24? What I suggest you do is you're going to list all the factors of 24. And I suggest you do them in the correct numerical order so you do not forget one. So let's go. What multiplies to 24? Well, we'll start out with the lowest. 1 times 24. 24 is even, so that'd be 2 times 12. What about 3? Yep, 3 times 8. What about 4? Yes, 4 times 6. What about 5? Nope. What about 6? Yep, we already got 6, so we know we're done with the list. So that's an important reason why you want to do your factors in the correct order. That way you know you've covered all of them. Now, you do not get to choose which set of factors you like better. It's not that way it works. You have to read the expression. It's telling you what it needs. It's saying, hey, I want to multiply to 24, but I also want these numbers to add to what's in the middle, which is 11x. Now you're going to say, well, none of these are going to add to 11x. I get that. But which of these sets of numbers are going to add to 11? Well, 1 and 24 add to 25. Out. 2 and 12 add to 14. Out. 3 and 8. Oh, that adds to 11. We're done. We have our numbers. Even if you want to check the other option, 4 and 6. 4 and 6 will not work. It only adds to 10. there's going to be only one set of numbers that does both jobs. You need a set of numbers that multiply to the last term and then add to the middle term. Now you're going to say, well, how do we get an 11x? Well, just remember, this is made with the outers and the inners. Here are the outers. What's x times 8? Oh, that's 8x. Inners, what's 3 times x? That's 3x. If you had a 3x and an 8x, would you get 11x? You sure would. Now you're still not done, because for these to be binomials, you need symbols in the middle. It goes back to all the rules we've learned. If you're saying we're adding, the signs must be the same, because we only can add terms that are alike. So either both of these are going to be positive or both of these are going to be negative. How do we decide if they're both positive or both negative? We listen. I want to multiply to 24. I want to add to a positive 11. And that's why we know both of these signs are positive. So x plus 3 times x plus 8 is the factored form of that trinomial. If you rewrite it and you write for me x plus 8 times x plus 3, that is also the factored form. Because remember, the commutative property of multiplication says it doesn't matter what order we write our terms in, we'll get the same result. If you say 3 times 8 and I say 8 times 3, we got the same answer. So that's how you factor a trinomial expression. Think of backwards FOIL. What we're going to do in our next video is change all the signs. They don't always have to be positives. I'll see you then.